Hello, can you hear me?
Yes, we can hear you.
Okay, good. So how's everyone?
Good.
Great. So let me share my screen as well. 1 second. Okay, so you can see my screen, right?
Yeah.
Okay, perfect. So by the way, about the timings, are you guys are obviously not going to school, right? Because you're preparing for NET. So you're right, no one is going to school or anything at the moment.
Yeah.
Okay, great. So I was thinking that if you're all comfortable, if it's possible for you all to even wake up around 9 a.m. So like we can basically have the class at 9 a.m. in the morning. Does that sound? Does that work for you?
Yeah, I don't mind.
Right.
That is
amazing.
not possible for me.
Oh,
I don't live in Pakistan, so it would be very early for me.
Yeah, same.
Okay.
For me, it will be 7 a.m.
Oh, right. So when do you think you can
This time is all right.
this
The
time
current
is all right?
timings.
Oh, okay. So I was actually trying to shift it to the morning for me as well, but it's okay. Okay, so
We could change it to night. I don't mind studying at night.
change it to night. And actually, I was trying to make it to more towards the morning for my time. Where do you live? What timings are you following? Am I audible? You can hear me, or did the connection drop? Let me check. Okay, you can hear me? Am I audible?
Yes, sir.
Okay. Okay, so I guess we'll discuss this timing thing. Okay, so is there any question from the last class that we did?
Yes, sir.
Yeah, of course. Go ahead.
Okay, so we have 20 topics, and how many days do we have? 15? 40?
Yeah, I think not wrong. I'll have to check, but I think it's in the mid of July.
The
NET.
NET? It's not in the middle of July. My exam is on 2nd of July.
Okay, so it's in the beginning, right. So it's in the beginning of July. Okay, so we'll have to pick up the pace, and I guess we'll spend less time on theory and we'll try more towards problem solving, because what I'll do is I'll make the problem solving session so you can cover most of the theory in the problems as well, right? So we'll pick up the pace, and if anyone has any problem, like maybe it's too fast for someone, we can you can let me know. So so I guess we'll just continue right now so that we can start picking up the pace. Is there any question from this thing as well, from what we did last time in the class? Is your question answered, like, or do you want to add something more to it?
No, it's okay. I was going to ask about the recordings, but it can wait.
Right. Yeah. So the recordings, I'm sure that they will be shared with you. I think you can personally drop me a message on WhatsApp with your email, right?
Okay.
So just do that, and I'll get back to you. Okay. So any question from what we did last time in the class?
No, not yet.
Okay. Okay. So we were doing this problem, and then the meeting ended. The call dropped. So do you want me to go through it once again from the beginning, or did you understand how we got this expression for error 3 by r dr times 100? All we did was we took the derivative of this expression for volume of a sphere, and we divided that with the volume so that we can find the fractional error, and then we'll just multiply it with 100 to find the percentage error in volume.
Why did we derive the volume?
Oh, right. Yeah. So basically, the question was that we were given the radius with some error, and we were asked to compute the percentage error in the volume of the ball. So we assumed that the ball is spherical. So we wrote an expression for volume of a sphere. And what is error? Error is basically the change in your value, right? So it's your standard value minus the experimental value, right? Yeah, exactly. So that's basically dr is your error. Fractional error is dr over r, and the percentage in that is, if you want to find the percentage fraction, so you just multiply it with 100, right? So that's what we want. So this is for radius, so we computed this for radius. Now we want to find in volume. Now this was the method of how do we get to this thing, and the next question, I'll just give you a rule where you can just follow that and find errors easily. You won't have to go through all this procedure. So anyway, this thing, it was 3 over r dr times 100. So that's what you get when you differentiate the volume and then divide it by the volume. And now you can write this as 3 into a dr by r times 100. But this thing is the fractional or the percentage error in r, which is this thing, right? So it was 3.8. Right? So is there any problem so far? I guess not, right? So this is just 3.8. So we'll multiply 3 with 3.8, and this side is the percentage error in volume. So I was writing it over here, percentage error in volume, which is equal to 3.8 times 3. So if you do the math, you get something 11%. So that's your option A. So is there any problem in this question?
No, it's fine.
Okay, perfect. So let's move on to the next question. It says that you have percentage errors in measurement of mass and speed are given. So they are 2% and 3% respectively, which means the mass is 2% and speed, the error in speed is 3%. How much will the maximum error in the estimate of kinetic energy be obtained by measuring mass and speed? So we know that kinetic energy is given by half mv squared. Now, if you have followed the same thing, you can either follow the same method, which is quite lengthy and it's not suitable when you're solving your MCQs, right? So you can just, there is just this rule where you can simply ignore the constants. You can ignore the constants and convert your plus or minus into, you will convert your multiplication or division into sum, right? And if you have, if any quantity has a power, so you'll just bring the power down, which just means that you will take that power as a multiplication. So I'll just write bring the power down. So I'll tell you what I mean. What I mean is, now if I have to find the error, so this is the expression for kinetic energy, right? Half mv squared. So let's find the percentage error in kinetic energy. It will be, if I follow these steps, so I'll ignore the constants, and I'll have, you have mass and you have v. We are given percentage errors in both of them. So the percentage error in mass is 2% and percentage error in velocity is 3%. Now, just in place of the value of m, we'll put the percentage error of m, and we'll just drop this constant, which is 1/2. So we'll just drop it. In place of v, we'll put 3%, which is the error in velocity. So we'll just add them, right? So there was this, they were being multiplied. So we just converted them to sum. And then we have v to the power 2. So bring the power down. So we'll just bring this power down, which will become 2 multiplied by, what is the error in v? That's 3%. So that's 3. So that gives you a percentage error of 8%. Right? So that's the percentage error in kinetic energy, which is option C, and that's your correct option. So is there any problem in this question?
No, but you could skip the steps, because these are the things we have already done. Like,
right. So exactly. So that's what I want you to let me. Yeah. So that's exactly. So that's what I want you to let me know. So yeah, let me know if I'm going very slowly, doing lots of things. So okay, that's great. Okay. So then we have this is a similar question. You have a mass m has acceleration a, it moves through a distance s in time. The power used in accelerating the mass is equal to the product. So they have given you, which I'm sure you already know, it is f dot v. It's expression for power. The percentage uncertainties in all of these expressions are given. So you know m, a, t, and s, right? So how can I write this in terms of these quantities? So I know f is equal to ma, right? And then we have v, but what is v? V is displacement over time, so s over t. So following the same rules, we have mas over t. So just percentage uncertainty in m is 0.1%, then plus in a you have 1%, plus s you have 1.5%. And even though there's a dividing thing happening over here, so ma is divided by t, we'll still just use plus 0.5%. So this gives you 3.1%. So everything is clear, right? Simple. The same thing as we did in the previous problem. The only thing was to expand
Yes.
f in terms of ma and v in terms of s and t. So with that, we can move on to the next problem, which is in the expressions below, a is acceleration, f is force, m is mass, t is time, v is velocity. Which expression represents energy? So using, we'll use dimensional analysis for this, right? So that we can verify which is the correct expression. So we know that a is meters per second. We know that f is newtons. We also know that m is kilograms, and we know t is seconds, with v is meters per second. So these are the units. Now we know E is defined as what? You can write it as force times the distance, right? So what are the units for E? This means that the units for E are the units of force multiplied units of distance. So we have newtons, and the units for distance is meters. So Newton meter, right? So you can see, if you look at these expressions, nothing will give you a new, I mean, if you look at this, for example, 2mv over t, you cannot get Newton meters from this, because m is kilograms, v is meters per second, and this is So we are not getting Newton meter. Even from this expression, you're not getting Newton meters.
Yeah,
So
see.
what you can do is you can put all the units in these options and you can check, or you can just use a little bit of common sense and see where you can get Newton meters or not. It's if I look at this expression F V T, what are the units? F is Newton, V is meters per second, and T is into seconds. So this goes away and you're left with Newton meters. So the correct option is option C. Any question?
No.
Right.
Okay, I have one
So
question.
yeah.
Yeah, so there are many formulas for energy, right? But
Yeah,
infinity,
exactly.
right? So we'll use a general formula, which is force into distance.
Yeah, exactly. All of your formulas, they have the same dimensions, right? So whether it be E equals mc squared, whether it be E equals force times distance or whatever, the dimensions of energy will always be the same.
Right. I just get that in my mind. Right.
Perfect. So okay, so we can move now to the next problem, which is, well, this is exactly the same problem, so I'll just go through it very quickly. We have resistance R of an unknown resistor. It is found by measuring the potential difference. So they're just telling you the expression for R in this problem, which is V over I. We have 3% uncertainty in voltmeter, and we have 2% uncertainty in ammeter. So what does ammeter measure? Ammeter gives you the value of current, and voltmeter gives you the value of voltage. So what is the uncertainty in the calculated resistance? So to find the uncertainty, I'll just put the percentage error in V plus percentage error in I, right? So percentage error in V is 3%, and in I it's 2, so we have 5%. So that's your correct option, B. So I don't think that you would have any problem in this one, right? Clear. Okay, so final question is, which one of the following is not regarded as a fundamental quantity in physics? We have weight, mass, length, and time. This is very obvious, right? Because if you know what are your base quantities, those are the fundamental quantities. Basically, mass, length, and time. These are your fundamental quantities. Whatever I make out of these quantities is not a fundamental quantity. So you can make weight out of these quantities. So weight is not a fundamental quantity. Is that clear? Because weight is made up of
Yes.
mass and g, but g is made up of velocity and time, and then velocity is made up of length and time as well, right? So okay, so we're done with first chapter, which was of measurements. Let's start with vectors and equilibrium. So if there are things that you that the entire class agrees that they understand. Okay, 1 second, we're having technical problem. Just give me a second. Okay, so until I open that file, you can, if there is any question regarding anything regarding first chapter, or is there anything that you want to add, or so you can just let me know. Is everyone following along, by the way? All right, so let me just share this.
Sorry, what do you mean by everybody is following?
Oh, I just meant that is there anyone who feels that I'm going too fast, or
No.
That's
Okay, one question. The questions that we did, is that all the type of the questions that we come in NHE, or are there more?
mainly these are the types, but again, we have Friday specifically reserved for doing questions entirely. So we'll be doing different types of questions on Friday as well. So yeah, we'll be doing questions. So for example, how much of this chapter, next chapter we'll finish, we'll also be including questions from this one, right?
Okay.
So Friday is entirely for questions. Okay, so let me share. I can completely understand your concern that there's not lots of time left and we are probably moving too slow. Okay, so we have this chapter number 2, which is vectors and equilibriums. So we'll go through the basic things very quickly. We know we have defined physical quantities. Anything that we can write the laws of nature is a physical quantity. Then physical quantities, they are divided into scalar quantities and vector quantities. Very basically, scalar quantities are something that only constitutes of a number, and a number is enough to specify everything about that quantity. So they're non-directional. For example, you have volume, mass, or even work, right? So you don't need a direction to specify mass. But a vector quantity, on the other hand, you need a direction and the strength of the vector as well, or you can say the magnitude of the vector. So for example, you have force. Force is a very good example, because let me just quickly give you an example. If I were to push this object, I say I'm just pushing it with 10 newtons. That information is not enough, because I have to specify where am I pushing it. So where am I applying this force? So if I'm applying the force in this direction, something else happens. The box moves in this direction. If I'm applying the force in this, so the box will move in this direction. So what happens after I apply the force depends on what direction I am applying the force, and hence that means force is a vector quantity, right? Similarly, torque and velocity as well. So that's clear. Then we have scalar algebra. So scalar algebra is pretty simple. They follow simple arithmetic rules. You can plus, add, subtract, multiply, and divide as you do normally, because they're just numbers, they're just constants. However, vector algebra is a bit different. It's a bit special, and so it follows some special rules where the multiplication, especially, it's in terms of if you know matrix multiplication, it's done a bit like that. And division does not work. So you cannot divide vectors. So now we can move on to modulus of a vector. And modulus of a vector represents the magnitude of a vector, right? So it's actually the numerical value of the vector. It will not give you any information about the direction of your vector. So if you want to just extract the scalar part of a vector, you can just find its modulus, which will give you the magnitude of the vector, right? So for example, you have vector A that says 5 newtons to the north, and vector B says -5 newtons to the south, basically, right? So that minus, if +5 is north, then -5 should be to the opposite of north, which is south. Anyways, so in that case, vector A is not equal to vector B, right? So because it constitutes a direction. However, if I were to simply find the magnitude of A, then the magnitude of A would be the scalar number that it has. So it's 5, and this is also 5. So the magnitude of both of these vectors is the same. So that's clear, right? So is there any problem so far?
No, it's fine.
Right. So, okay, now let's discuss behaviors of our vectors. Now, a vector basically will not change at all if I displace my vector parallel in space. What it means is, so if I have this vector, and you can see these two vectors, right? So they are the same vectors basically. So if I have a vector like this, I can displace it parallelly anywhere, right? So I can put it here, I can put it here. Wherever I put it, the vector is not changing because the arrow still points in the same direction and the length of the vector also does not change. And the other thing is that if I rotate my vector with an angle of 2 pi and I rotate it n times, it would not change it. Because rotating by 2 pi just means that I'm just rotating this vector like this with a complete 360-degree rotations, and it comes back to its same direction. So I can do this n number of times. It would keep on coming back to its same direction, and hence this rotation does not change the vector. So you can say that the rotation of 2 pi n keeps the vector invariant. Now, when does a vector change? A vector will change basically if I were to change the magnitude of this vector. So if the vector was like this and I say, no, I add something else to it, so the magnitude of the vector changes. And hence the vector is not the same as it was before. Or you can, if the vector was pointing like this, you change its direction, you make it point like this or whatever, then the vector changes. And obviously, if both of these changes happen, then the vector will change as well. So is that clear?
Yeah.
Okay, perfect. Now, quickly, just the angle between a vector, actually two vectors, right? So suppose you have two vectors A and B, their tails and the tails of the vector must be at one mutual point, right? So here we have this is that point and the tails join at this point. Then the angle between these two vectors A and B is given by this angle theta. So that's how you measure the angle between two vectors. And we'll see more about this moving forward. Now we have coordinate systems. We have multiple coordinate systems. One of the coordinate system is known as rectangular coordinate system, which is also called the Cartesian coordinate system, right? Now you can have different types. You can have even there are one-dimensional, two-dimensional, three-dimensional. You can even have a four-dimensional, but that's not the part of your course, right? So in a two-dimensional coordinate system, you have x and y axes, right? And these axes are such that they are perpendicular to each other and they intersect mutually at one point. Now, the point there where these two axes will intersect is known as origin, and you only require one angle that moves from x-axis to specify the direction of the vector that lives inside this xy plane. Now, on the other hand, you have a three-dimensional coordinate system, which consists of x, y axes, of course, but there's another axis, z axis. And your normal world which you live in is also spatially three-dimensional. So you have x, y, and z. Now, the important point over here, one of the important point is that it doesn't matter what you label your x, y, or z. But once you pick one coordinate system, then you solve your problem in that particular coordinate system. In fact, choosing the right coordinate system for your problem is the key to solving your problems in physics. And this is something that you eventually learn, especially when you go into your university level. At least it was for me that way. I was never told about this thing. So choosing the right coordinate system will make life very easy. And again, it consists of three axes that are mutually intersecting at a point. That point is origin. And to specify a vector inside this three-dimensional coordinate system, a vector that lives inside this system, you need three angles. One of the angles is measured from the x-axis. The other one is from the z-axis, and then from the y-axis. Okay, so any question up until this point?
No, sir.
No question? Yes, you have a question?
No, I don't.
Oh, okay. Okay. So we can move forward. Okay, now we have this thing which is head to tail rule, and we just use this to basically add our vectors. And it's very simple. What you do is when you represent your vector graphically, right? So if you have, suppose you have a vector v, now you put it like this. And suppose, so let me just, can I separate them like this? No, I cannot right now. But you have a vector v1 like this, any vector v1, and you have another vector, let's say it's like this, v2, it's over here. What you can do is, I can simply take this v2 and I'm just moving it parallelly. So it's still parallel to its original direction it was. And I can put it over here. So what I've done is I've put v2 on the v2's tail on the head of v1, and then I join from v1's tail to the head of v2. Whatever this vector is, it's the sum of these two vectors that I started with. It's normally called a resultant vector, right? So that's why, now let me clear this up a bit. I'll just move it over here. And so the resultant vector is the sum of v1 plus v2, and that's how you can add your vectors. Now, let's move on to how you resolve your vectors. You can resolve your vectors into components, right? So resolving a vector basically means writing different components of your vectors, right? So it's also it's a reverse process where where we have added our vectors. Now we are just breaking it down back into the components, right? So for example, I have this coordinate system x, y, and I have a vector lying in this coordinate system. The component that is parallel to y-axis is the y component, and the component that is parallel to the x-axis is the horizontal x component. And the angle between this vector and the x-axis is the same as the angle between the vector and the x component. Now you can use your trigonometry, and you can work out these components of the vector. So vx is v cos theta and vy is v sine theta. So is there any problem with this, or should I explain it a bit more in terms of how did we get these expressions? I think it's clear, right?
Yes.
Okay, perfect. So now what if I add these two vectors? Now I need some information about the direction as well, which this angle theta will tell me. So I can derive an expression for theta by simply squaring these two, vx squared and vy squared, and then add them together. So once I do that, I get something that looks like this. And I can just factor v squared outside. And then this thing from trigonometry tells you that this is just unity, or its identity, or one, whatever you want to call it. And then we are left with v squared. So basically, it's telling you that v squared, the modulus of your vector, is given by square root of vx squared plus vy squared. Because remember, on the left-hand side, we had this thing. So that's how you can find the magnitude of, or the modulus of a vector. Now, if I were to divide these two expressions with each other, that would give me the information about the angle theta. So what I get is vx over vy is v goes away, and we get, well, I think there's a mistake over here, because obviously vx over vy will not give you that. Vy over vx would have given you that. So this is vy and this is vx. So you can work out how we can get to this expression, right, from this thing. So just divide, you have v sine theta divided by vx is v cos theta, and this is equal to v y by vx, right? And so v goes away. This is tan theta, which is equal to vy over vx, where theta is tan inverse of Vy over Vx. So that's clear, right?
Yes.
Perfect. So can you let me know how much time is left for the meeting?
Let me check. I don't think we can check that.
Oh, you cannot, even I cannot check it in that.
Okay, once
That's
the
weird.
meeting ends, you can just restart the meeting. That happens because you do not have the membership, right? And if there's more than one
Exactly.
student.
Okay, so I can rejoin the link and it will continue from there.
Yes, yeah, because you use the same link, right? Every day.
Yeah.
Yeah. So end the meeting and then restart it. It will give you
Right.
another 40 minutes.
Okay. Right. Okay. So now let's come to scalar product. It's also called the dot product of two vectors. Now, if you have two vectors, you can multiply them in different ways. One way is to take the dot product of the two vectors, and the other one is to take the vector product, which is known as the vector product of the two vectors. So if you have two vectors A and vector B, then the dot product between those two vectors is defined as AB cos theta, where this thing is just